Hi guys, my name is Fischer, and today we're going to be finding the mole fraction composition for a mixture of two gases. So the problem we're going to be looking at is number 74 on page 617. The problem reads, a solution contains a mixture of pentane and hexane at room temperature. The solution has a vapor pressure of 258 torr. Pure pentane and hexane have vapor pressures of 425 torr and 151 torr respectively at room temperature. What is the mole fraction composition of the mixture? Assume ideal behavior. Okay, so the equation we're going to be using is the total pressure, P total, is equal to the mole fraction of substance A times the vapor pressure of substance A plus the mole fraction of substance B times the vapor pressure of substance B. So the problem states that the vapor pressure of the solution is equal to 258 torr. The vapor pressure of pentane is going to be equal to 425 torr. And the vapor pressure for hexane is equal to 151 torr. Okay, so in this problem, we're going to be looking for the mole fractions. Since we know that the mole fraction is going to add up to 1, we can use the variables x and 1 minus x in this case. So to start off the equation, we're going to do the total vapor pressure of the solution, 258. We can kind of drop the units since the mole fraction is going to be unitless. And we're going to say that the first variable is x. And we're going to use the vapor pressure of pentane, 425, plus the next variable is going to be 1 minus x times the vapor pressure of hexane. All right, so now we're going to multiply the variables across. So you get 258 is equal to 425x plus, we're going to distribute these, 151 minus 151x. Okay, so the first thing we're going to do is add the variables together. Minus 151. You're going to get 274x. Now we're going to subtract both sides by 151. Now we're going to find x. We're going to divide both sides by 274. And we're going to get 0.391 with significant figures. So we have 3 significant figures in the problem. And that is going to be the mole fraction for, what do we say x was? Pentane. Now to find the mole fraction for hexane, we're going to remember we used 1 minus x, and in this case x was 0.391. 1 minus 0.391. That's not right. 1 minus 0.391. We're going to get 0.609 as the mole fraction for hexane. Now, if you remember from the beginning, the vapor pressure of the solution is 258 torr. If you look at the mole fractions, this is going to kind of make sense since there's more hexane in the solution in moles than pentane. The vapor pressure of the solution is going to be closer to the vapor pressure of pure hexane. Okay, so these are the two answers. And to sum up, we had a solution with a mixture of pentane and hexane. We had the vapor pressure of the entire solution and the vapor pressures for pentane and hexane. And we found the mole fractions for pentane and the mole fraction for hexane. Thank you very much, and thanks for listening.